Hi and welcome to today's session on properties of triangles. So when we're talking about properties of triangles, there are four main types of triangle that we need to be aware of, and these are shown here. So first of all, we've got our right angle triangle, and of course it's a right angle because we can see here that there is a right angle in that triangle. We've got our isosceles triangle. Now, this is defined because we've got two equal sides, a pair of equal sides, and we've got a pair of equal angles at the base of this. And as you can see, it's got one line of symmetry. Just at the bottom here, we've got the equilateral triangle. Now, this means that all three angles are equal, as well as all three sides are equal, defined by this dash on the edges. And as you can see, it's also got three lines of symmetry. And the last one is our scaling triangle. Now, as you can see, this is none of the sides have got equal length, none of the angles are equal, and there's no lines of symmetry. So, when we are looking at triangles, we could label these to actually identify different sides of this in respect to exactly where the angle is. So, the longest side of the triangle is always going to be the hypotenuse. The side opposite our angle marked with X is called the opposite. And at the bottom, we've got our adjacent, which is our line just right next to our angle, which is what adjacent means. It means right next to. Now, this is especially when we are talking about trigonometry, we are going to be using these properties just here. But when we are labeling triangles, we can actually label them using letters. A lot of time they are labeled in a clockwise or anti-clockwise direction. So first one that I've got labeled here, I've labeled my angle with a capital A, and the side opposite the angle I've labeled with little a. Done the same for B, labelled a side with a vertex with B, and I've labelled the edge opposite the vertex with a smaller b. Now, as you can see, I am heading in a clockwise direction, and my last side is a capital C, and the edge opposite this is a little c. And we can shorthand write our naming this triangle as little triangle A, B, C. So this is just a little quick shorthand way of writing it rather than writing triangle A, B, C. So, as we saw before, equilateral triangles, they are regular polygon because all the internal angles are equal and all of the sides, our edges, are equal. And we could be asked to calculate angle A. So the angle just in the bottom left-hand corner of this shape. So if we use the properties of a triangle, the angles within a triangle add up to 180 degrees. That is a fact that you'll be using throughout mathematics. So there are three angle A's because all these are equal. So A plus A plus A has got to equal 180 degrees. So if I divide 180 degrees by 3, that's going to give me the value of A, which is 60 degrees. One single angle in an equilateral triangle is 60 degrees. We can also use identities, use properties to try and work out internal angles of an isosceles triangle. So here I've got an isosceles triangle. I've been given the angle of 88. Calculate the angle A. Now, of course, isosceles triangles, the angles at the base of the triangle are equal, in which case I'm counting this as my base. The base does not always have to be the part lowest on the page or the part that's flat. Here, this is my base, in which case, what I'm going to do, I'm going to use the fact that there's 180 degrees in a triangle, and what I'm going to identify first of all is that all three of these angles are going to add up to give me 180 degrees. Which means if I simplify this 88 degrees plus 2a, 2 lots of a, equal 180 degrees. So now if I subtract 88 degrees from both sides, so 2a is going to equal 180 degrees less 88 degrees, which leaves me with 92 degrees for both of these two angles. Now if I was to halve that, that will give me one angle being 46 degrees. And there, that's calculated. If you like what you see, please subscribe. Thank you very much for watching.